Welcome. I'm here to present to you my internalized lesson plan. I chose the lesson plan Introduction to Limits in Calculus, and I chose this mainly because my math subject of choice in high school would be to teach either a STEM pre-calculus or calculus course. I want to prepare my students for college level mathematics as an 11th and 12th grade instructor. Okay, so on the right is a snippet of my lesson plan. Okay. Project overview. I made several. First off, I made several modifications to the overall lesson plan. I modified the framing lesson section by including the need to give a good formal definition of the limit as opposed to only a good example of what a limit is. So I actually want a formal definition given so that students can have basically a good definition of what a limit is, not only an example. Okay. Next, I modified the ownership by giving the students a variety of problems that were adapted to a diversity of learning abilities that the students could choose from and solve. And then I modified the student ownership to have the students write down, giving an explanation and a definition of the limit in their own words. Okay? So I want them to give their own explanation of what a limit is in that part of the lesson plan. Also, I modified some of the materials. I modified the standard graphing calculator to CAS-ready calculators to help the students check and monitor their learning, since it has symbolic notation and can calculate and can use an algebra system to give symbolic answers as opposed to just numerical ones. Learning objectives to TEKS. So the first objective was an objective 1D in pre-calculus. Students can understand graphically how to compute the limit and also how to analyze and use proper notation when computing the limit written as a symbolic function. They will be able to compute these limits when a limit is represented in a variety of forms. And then the second objective I chose was a pre-calculus objective, 1G. In studying and having the students give a formal definition of a limit and communicate in their own words what a limit is and what it computes by giving well-established examples teaches the students how to organize and express an idea in mathematics using mathematical language. Okay, so they were able to basically, with the terminology given, give their own explanation of the formal definition of a limit, be able to communicate their mathematical ideas. So on the left is the materials and bell ringer portion of the lesson plan, and I made several materials adjustments. As said, I had specifically wanted to use CAS-ready calculators as opposed to standard graphing calculators, which would allow the students to more effectively check their work. Okay, I'd also have to add the graphical worksheets. So these worksheets would be basically graphs with holes and dots on various coordinate points on the graph. They'd be with holes or dots where the graph, if it's a dot, the graph exists. If there's a hole, the graph does not exist. And this would ensure visual comprehension of the graphical limit analysis and recognition. Okay. And some of the bell ringer adjustments I would have made is I would have added to the framing part of the lesson limit problems involving functions and work on the whiteboard how the newly discovered concept connected to a function and a graph and an actual problem. Okay. So this would help the students graph or bring the two ideas together as they see the same idea happening on a graph of a function. I would also have students write their bell ringer responses down on paper. So basically, in the bell ringer, the question was, can you reach a wall if you move halfway toward it every time you take a step? If you can actually apply this analogy to an actual function problem, then it's good to connect the two ideas. And that's how I would adjust the bell ringers to actually put some, use it to solve the limit of a function using that same analogy and help connect the two ideas for the students. Okay, framing the lesson. On the left is the framing the lesson portion of the lesson plan, and then with activating prior knowledge, my teacher prompt to understand the definition and apply that knowledge to solve a limit problem, think back to the bell ringer. The wall we are walking toward on the other side either exists or it doesn't. but the point is that really doesn't matter since we approach the wall but never quite get there. So basically it's saying even if the wall didn't exist, the limit of the wall would. The overall limit, what we're approaching, would still exist. And I would ask the students to use this knowledge to solve the limit problem. And the adaptation, I would have students get in groups and create other scenarios where limits would exist, where the other side, whether it be the other side of the wall or an edge or a cliff or something like that, it would be a similar kind of example, whether you're walking towards the edge of a cliff or to the other side of a wall. And then this will give the students a visualization when actually working with numbers and coordinate points on a graph, to have them solve something, a function such as x squared, as x gets closer and closer to 2. Well, what does y approach in the relationship? Okay, and then the relevance to the real world, I would say imagine another instance of the limit where a driver slows down at a stop sign. He doesn't stop immediately, but if he stops, what speed is he approaching as he's slowing down? I would allow the students to discuss in groups or discuss the answer as an entire class and come up with a way of explaining what the final speed of the car must be and how the limit applies to that speed being approached even before the car gets there. So that's kind of a real world example of what the limit looks like. Okay, just like the bell ringer. And then in the context, why do you think limits are important in mathematics, and how do you think they are used to solve a variety of problems in calculus? Later, and I would let them know that later we discover the significance of limits in other sections of calculus. So I'd give some quick examples of the usefulness of the limit in other areas of mathematics after letting students brainstorm and share their ideas of limit uses and importance. And then I'll do some vocabulary review. Let us review some of the terms you will be needing to know and understand the concept of a limit better in this section and in the sections to come. So I'll use a PowerPoint with listed terms and definition table as seen to the left and have students copy the definitions on a sheet of paper for future reference. So I want the students to know these definitions very well in order to understand fully what a limit is and how to use a limit. Concept development. And on the left is the portion of the concept development portion of the lesson plan and a table. And in the modeling, this is my teacher demonstration, display the notation for the limit operator. So I'd let them know what the limit operator looks like for any function evaluation and explain that LIM is short for limit. So it's basically an operator that operates on a function and calculates or computes the limit of the function. Okay. We may also use L equals the limit to show that L is the value approached in the function as x tends towards some arbitrary value a. Remind the students that when taking a limit that the function doesn't have to exist at the point, and give the students a graphical example. Explain the function doesn't have to exist because when we take the limit, we are actually calculating what point on the graph we are tending toward, not necessarily the value at the point itself. And then we transition to guided study, what we do for 8 to 10 minutes. Whole class analysis. Give the student a problem to work together and walk them through the example scaffolding and making comments on their responses through each step as you ask questions and work the problem. Provide a table beforehand and let the students analyze the table and take turns making comments and giving answers to the limit. Give and deduce the value of the limit and give the reasons as to why they chose the answer. So based on this table to the left, they can basically come to a conclusion what the limit will be at x equals 2, or what we're approaching as x approaches 2, just by looking at the information on the table. So now we're going to check for understanding, show the students the answer, and explain whether or not their thinking was correct, why or why not. Okay. Differentiation strategies. On the left again is a portion from the lesson plan on differentiation. And I made a couple modifications to the differentiation to each one of those categories for struggling learners, for English learners, and for advanced learners. So the additional information would be I would give the advanced students more complex functions and have them integrate their knowledge with future calculus concepts, getting a better and more general grasp on calculus overall. Okay. And for the English learners as well, I would pre-teach vocabulary as I would review notation and let them explain the notation in their own words as well as the definition of a limit. So to understand the definition of a limit better, I'd have them review the definition of a limit and pre-teach all the vocabulary so they have a more solid understanding of what a limit is and how it's used in mathematics. For struggling learners, I would let them use calculators and their functions also to guide them to learn and see the limit being computed on a cache-ready calculator, which are very visual and aid in computing the limits because they give you symbolic answers and help you much better understand and basically check and monitor your learning. So, independent practice and exit ticket. So to the left is part of the lesson plan, once again, for independent practice and exit ticket. And my response to the exit ticket is basically, in your own words, define a limit. Well, a limit is the value the dependent variable in some function tends toward as the independent variable approaches some value. Okay, and then we have to evaluate this limit as x approaches 5 for x plus 2. Okay, so right, using the notation, the limit as x approaches 5, x plus 2. Okay, so we know that when we evaluate this limit at where we approach 5, we get 7. Therefore, the limit is equal to 7, and therefore 7 is the limit of the function. Whether that value at 7 exists or not, the limit still exists because we're approaching that value and becoming infinitesimally close. True or false? A function must be defined at a point for a limit to exist, and that would be false. And now I'm going to explain my answer to question. So I'm going to explain my answer. Since the function is tending toward the limit L as x approaches 5, then the function limit does not need to be defined at that value since it is only very close. Okay? So the function doesn't necessarily have to exist for the limit for us to get very close to that very value. There could be a hole there where the function doesn't exist, and nevertheless the limit still exists. Homework and student ownership. At the left is a portion of the lesson plan concerning homework and student ownership. Create a real-world example of something approaching a value. Well, I can give an example. On a thermometer, if the day continues to get hotter as the day progresses on a hot summer day, the temperature will approach the day's high temperature. As the temperature is rising, we are defining the limit as it continues to grow closer and closer to the high temperature, whether it reaches it or not. So that's a perfect example of a change in temperature. As we approach a high for the day, we are getting closer and closer to the high, whether we get there or not, or if it actually does get there according to the prediction. We are getting closer and closer to a particular temperature over a period of time, and that shows that we are approaching the value, which would be the limit of the temperature for that day. Explain a limit using words, numbers, and a graph. Okay, if there's a function x squared and we want to find the value L as x approaches 3, we must find the function's value, whether it exists or not. That value, the value it would get closer to. Evaluate the limit. So 3 squared is 9. So if we evaluate the limit, L equals 9. So 9 is the limit of the function as x approaches 3. So in that function x squared, you see where there's a hole or a dot, either way, either at that point on the graph, y equals 3 squared is 9. So 9 is the limit, whether the function value exists or not. Then it says self-assess their understanding using a scale, and I say my self-assessment is a 4. Okay, student ownership. Limits are important in understanding change and motion because if something is moving, we say it is approaching a value at a rate, just like the thermometer example. What we want to know is that the rate and the speed it's approaching at any point close to the limit, how close are we getting before it stops? Limits are used to calculate change of motion at any point close to the value to determine its instantaneous rate of change by using the derivative, which uses limits to find the change in a rate very close to a certain point on the graph. Okay, this represents the change in position or speed or whatever variable must change in calculus. So we'll use limits when we study the definitions of derivatives later on. So this is kind of like basically preparing for the next lesson. You're basically giving your understanding of how limits can be used in a variety of areas of mathematics or calculus, especially when you're concerning change in motion. In my conclusion, I felt this project, the internalized lesson plan, helped get me an idea of the structure of a lesson plan and how to modify and enhance the lesson plan to fit my own teaching practice. I gained a sense of organization and was able to better orchestrate how I would present new ideas and concepts to the class, as well as find ways to present and make the material understood by using the organization of the lesson plan to help guide me in my teaching. I found this project helpful in exposing me to create my own lesson plan. I have gained a much better, more insightful, and by far more complete understanding of the limit to the extent I feel comfortable teaching the concept of a limit to a calculus class. So each detailed step of the lesson plan gave me deeper insight on how to make information fully and completely relevant to the learner through examples and deep exploration of what a limit is and how it is used in a variety of fields of mathematics and further into calculus. Since I am passionate about teaching any college level entry math class, such as calculus or STEM pre-calculus, to a diverse set of learners, I find I very well implement the structure of this lesson plan to organize my lessons in my classroom. I would definitely want to use a lesson plan structure like this one to organize my future teaching. I want to give examples such as the man walking to the other side of the room, as well as mathematical examples and definitions to well establish the concept of a limit in my classroom.